All right, hello everybody and welcome. We are here in chapter 6.2. And again, this is in the Holt-McDougall algebra curriculum. In chapter 6.2, we are going to look at how to solve linear systems by substitution. Again, our learning target over here is our Common Core State Standard, solving systems of linear equations exactly and approximately, focusing on pairs of linear equations in two variables. Specifically, in this particular video, you are going to use the substitution method to find the solution to a linear system, and that is, i.e., find the intersection of two linear equations, because again, that's all a system is. A system is finding the intersection point, the point where two lines cross. And you are also going to use solve a system using the substitution method in a given context. So, what is the substitution method? Well, the main goal of the substitution method is to find the value of both variables in the equations. So, for example, if you had x plus y equals 1 and y equals 3x plus 2, and that is your system, the goal is to find the x and y values in this system. And again, that x and y value is going to correlate to a point where they intersect, right? Because that is the value where they're both going to be equal, where they both make true statements. That's what we did in section 6.1. So the way we do this is in 3 steps, and the 3 steps sound maybe a lot easier than, or less work than it is, because there is a considerable amount of calculations we do have to make to do this. In step 1, the first thing we do is solve one of the equations for one of its variables. And remember, when I say the word solve, what I mean is to isolate the variable. So the first thing we need to do is solve for a single variable. Kind of like what this one is right here. How that y is by itself, it's been isolated, right? That's what that means. We need to make it so that one of the equations has a variable isolated. Once we've done that, what we're going to do is substitute the expression from step 1, that is this expression right here, into the other equation and solve for the other variable. So we're going to take this expression right here, and we are going to replace it in the other equation for the variable y. And then we're going to solve that equation. And then once we've done that, we're going to substitute the value from step 2. So step 2 is going to give us like an x equals some number. And then we're going to substitute that value back into the equation, the revised equation from step 1, and solve it to find the other variable. So let's actually put those steps together so that you can kind of see it in action. So here's our first example. And so step 1 is to isolate the variable in one of the equations. So that's actually done for us, right? Step 1 is done for us in this one, because if you will look, this very first equation has been solved for. The y has been isolated. So step 1 is already complete. Y equals 3x plus 2. Step 1, we have isolated the variable. Okay. Step 2 is the step where we substitute. Now here's the part where it gets a little bit maybe abstract, okay? So here we have y equals 3x plus 2. The variable y is the same thing as this expression 3x plus 2, okay? So what we're going to do is go into the other equation, and instead of writing y, so we would have 2 times y, we're going to replace the y with 3x plus 2. So let's rewrite the equation with that substituted in. X plus 2, but instead of writing y, we're substituting the thing that y is equal to, 3x plus 2. So that's going to be in parentheses 3x plus 2. And the parentheses are important because it's 2 times y, So it's 2 times everything that y is supposed to be equal to, and that's 3x plus 2. So now we need to substitute and solve. So notice how this equation only has one variable now, just the x. So now we need to solve this equation and get the x by itself. So we'll distribute the 2 and get x plus 6x plus 4 equals 11. Then we'll combine the x's here. 7x plus 4 equals 11. Now it's become a standard linear equation that we have been solving for quite some time. We're going to subtract 4 from both sides. We're going to get 7x equals 7. And then we're going to divide both sides by 7. And we're going to get x equals 1. So we actually have half of our solution. We have the x value. That's great. But we're not done yet because we need, it's an ordered pair, right? We need the x value and the y value. So here we have a value and we need to go to step 3. And step 3 tells us that we need to take the value from step 2 right? Which in this case was x equals 1, and substitute it into the first equation, the equation that we had originally solved for. And that equation is the y equals 3x plus 2. Because look what happens when we do that. When I substitute the x in for the x in the equation, I get y equals 3 times 1 plus 2. Well, there's no x's in this equation now. If I were to solve this, I would end up with the y value. So there we go, 1, 5. And that is going to be the solution to this system of equations. It is the intersection point. Now we can check this just like we checked it in the last one. If we take this point and plug it into both of our equations, 5 equals 3 times 1 plus 2, that's 5 equals 5, so that's good. And then we can also go 1 plus 2 times 5 equals 11, that's 11 equals 11, so that's good. So it checks out, right? The 0.15 checks out. And that's what we've got for this video. That's how we do the substitution method. There is a problem back for you to do on your Canvas account if you want to check that out, or you can look at the next video and then do the problem. Do it yourself first before you look at how that one's done. So we'll see you in a little bit. Go try this one. Go try this problem.